Hello there, my name is Dick Wyn, and all throughout this week I've been talking about my experience learning computer science and programming. And to round up this video series for Computer Science Education Week 2020, today I'm going to talk about the skills that I feel that every aspiring software engineer or software developer needs to master in order to be successful in their career. And that skill is debugging, which is a process of identifying and correcting an issue with a piece of code or a function within a software system. But before we get on with that, if you're new here, like and subscribe. I make tech, food, and lifestyle videos on this channel. This video is the last one in my series for Computer Science Education Week 2020, the week dedicated to raising awareness for computer science education. I'll leave the full playlist down in the video description if you want to check them out after you're done with this video. The reason why I say debugging is an essential skill for software engineers or software developers alike is because bugs are sort of a byproduct of code. The fact is that nobody writes perfect code on their first try. Like earlier this week, I talked about how learning to code is easy and accessible with all the free resources that are currently available on the internet. Learning how to write code is one thing, but learning how to write code that works as expected is another thing. And that second part is usually what frustrates and kills the motivation train for beginners. For example, when I started my first developer job right after graduation, one of the first things that I was tasked to do was to fix some bugs that were present in the project that I was being onboarded to. At that point in time, I've only debugged and fixed code that I've personally written myself or code that I've seen my fellow classmates write. I had no experience debugging code that was written by somebody else that I didn't know. So it was a pretty exciting challenge to take up. As I soon realized, the task of debugging someone else's code wasn't as daunting as I thought it would be. I managed to fix the bugs, and through the process, I learned the importance of writing maintainable, well-documented, and properly scoped code. Like the majority of time I spent to debug the code was me trying to understand how a function or a method worked. And yeah, that first-hand experience is really why I believe that debugging is an essential skill or ability to have as a software developer. It not only gives you insight on how to identify potential bugs that might come up as you're crafting a solution, but it also serves as a reminder to write code that can be easily understood, so that when a bug arises or a requirement changes, the code can be easily updated. Before I continue on, I'd like to explain why bugs happen in the first place. And just in case if you're wondering why bugs are called what they are, it's because back in the early days of computing, when computers were large enough to fit in a room, physical bugs did manage to get into the circuit board and vacuum tubes, which ended up causing issues for the computer. Admiral Grace Murray Harper called the removal of the physical bug debugging, and that term has since then been used to associate the act of fixing a computer issue. But going back to talking about why bugs occur, to do that, I'm going to use one of my favorite ways to describe what programming is to a person that does not have a technical background. I'll say something like, when I'm programming, I'm basically telling the computer through a special language to do something in a specific order. And the reason why I'm bringing this up is that if you think about it, computers are just really good at following instructions. Unlike what pop culture portrays computers as AIs with a mind of their own and that they will one day take over the human world, that's not really the case here. So whatever you tell the program to do in code, it will just follow whatever you had there. That means that you need to be very verbose or exact on what you want your computer or your program to do. And that specificity in programming is basically how bugs are formed. So bugs are essentially unexpected behaviors of a software system. Like one of the common bugs that I run into when I'm learning a new programming language or technology is that I see a lot of red errors that traces on the terminal that indicates that some code broke somewhere in the code base. And that usually happens because I didn't fully read the documentation and miss out something like a method initialization for the code to properly work. Adding to that, bugs are also caused by a variety of factors like not taking into account a specific scenario, an incorrect calculation, misinterpreting a requirement, or even something simple like using an incorrect value for a function. All of these things can lead to the code to not work as expected and thus needing to be debugged. Now that I've gone through a pretty long-winded explanation of what a bug is, I'm going to walk you through the 3 steps that I take when debugging a piece of code. And to help me better explain these steps, I'm going to use a bug that I found on my personal website a few weeks back as an example. This bug is about the dark mode toggle on my website. The toggle wasn't properly updating to reflect the current site theme when the page is refreshed. The very first step that I take is to assess whether or not a bug is actually a bug or a feature. Like this might sound trivial, but hear me out on this. As I explained earlier, a bug is nothing more than an unexpected behavior, and this definition of a bug lays the premise for labeling the bug as a feature. So if you set the expectation to the end user that the behavior is a feature, then they will not regard it as a bug and take it as a feature. For my personal projects, I usually don't spend too much time harping over whether something is a bug or is it a feature, but it becomes more helpful to do this activity when I'm debugging code for work, where I'm working with stakeholders and clients that focus on things like cost and value to the end user. So going back to the dark mode toggle bug that I talked about earlier, I'm classifying it as a bug because it provides a bad experience for the end user. Like every time the user changes a theme and refreshes the page, the theme is retained, but the dark mode toggle icon is always displayed as automatic. The next step I take once I've determined that the issue is a valid bug to fix is try to replicate and isolate the problem. That helps me narrow down the chunk of code that is potentially associated with a bug, figure out the feasibility of a fix for a bug, and more importantly, ensures that I'm just fixing only one bug. I'm saying this because I've debugged multiple issues together in the past, and it sometimes does save me some time, but it usually just overwhelms my thinking and can lead to a creation of more bugs. Going on with the example bug from my personal website that I talked about earlier, I'm going to try and reproduce that on my local machine here. So I have my website here running on a local server, and I have it open in an incognito window just to simulate it as a new user entering the website for the first time. So as you can see in the top right corner here, I have the dark mode toggle. Right now it's set to automatic, but if I click on it, it'll cycle through. This is dark mode right now, and I cycle it once again, it goes to light mode, and then I cycle it again, it goes back to automatic. So the way that automatic works is that it follows the theme of my system. So my system is currently set to dark mode until sunrise. So what I'm going to do right now is to try to replicate that issue where I switch to a theme and I refresh the page and the icon does not retain back. So what I'm going to do right now is go to switch to light mode here, and as you see, just take a note at the icon and the dark mode toggle in the corner there. I'm going to refresh the page, and as you can see, it goes back to automatic mode here. But as you can see, the theme, it retains to light mode. Because if it's actually automatic, it should follow the same theme as the system, which is right now dark mode, but it's not. And now what I'm going to do here is to open the DevTools to check out what's going on. So for my dark mode toggle feature here, what I'm doing is that I'm using the browser's local storage in order to store the user's preference for whether or not they prefer dark mode, light mode, or just follow whatever the system is using. When the mode is automatic, there shouldn't be any local storage key that's being logged on the website. So as you can see here, the dark mode key is properly set, so it's set to false. Dark mode is set to false, meaning that it's a light theme. So that shows that the application is properly saving the theme that the user selected, but the icon itself is not being properly updated here, because if it's automatic, there shouldn't be any dark mode key or anything in the local storage. So that's basically the end of this second step. I've managed to reproduce the bug, and I think I know what's causing it. It's not the logic that sets the user preference for a dark mode theme, but it's more of how the icon or the dark mode toggle icon is being saved or being set. The last step that I take before I start to make changes to the actual code is just to write it out as a list of steps that mimics how the code progresses, or to draw a diagram. I used to doodle on some scratch paper, but recently I invested in this iPad and this Apple Pencil to do just that. Alternatively, you can use digital tools in a computer to do this, but I personally feel that drawing it out or writing it out physically helps to better visualize the problem. So to visualize this bug here, I'm going to turn to my iPad here. I'm going to draw the 3 states of the dark mode toggle. So first I have automatic here, okay? And then we have the dark mode, which is by the moon symbol. And then we have the light mode, which is by the sun symbol here. So when I'm navigating the states here, so when I click between automatic to dark mode, what I'm doing under the hood is basically setting the local storage. And then dark mode, I'm setting it to true, okay? And when I'm going between the dark mode to the light mode, what I'm doing is that I'm setting the local storage to dark mode to false. And when I'm clicking from the light mode back again, what I'm going back is basically I'm going back to the automatic, where I'm setting the local storage here. And then I'm basically the dark mode, I'm deleting it. So I'm gonna label it as this is step 1 here, step 2, and step 3. So going back to the reproduction state that we were talking about previously, if we were in this second state here where we're in light theme and we refresh the page. So we're going to refresh the page, okay? And what happens is basically the automatic mode comes back, but that's not what we want. What we're wanting is actually the light mode to come up. So this is what we want. So from this diagram here, we can see that yes, the state is correctly represented here. So this entire state here, the state number 2, is being properly represented in the application storage or the browser storage itself. And so through this diagram, we can see here when a refresh happens, what is actually happening under the hood is that this local storage value is there, okay? This local storage value is there, but the icon is not properly being represented here. So this is being shown opposed to this, which is what we want. We don't want this. From this diagram that I just drawn here, I can infer that the bug is due to the page not properly reading in the dark mode local storage key when the page loads. This site is written in React, and that means that I'll need to add a lifecycle hook to read in the local storage key from the browser so that the icon will be properly updated when the user refreshes the page or when the page first loads. So yeah, that is basically how I do debugging for a personal project or for work. This example is a rather simple one, but when it comes time to solving something more complex, these 3 steps will be more valuable in effectively fixing a bug. As a whole, writing code is a continuous cycle of trial and error, and the whole process can be immensely frustrating even for experienced developers. Let me know down in the comment section below, how does your code debugging workflow look like? Do you use any tools like an iPad or a digital notebook? Or do you use some pen and paper? Or do you just go directly in the code to just make changes to see like if something works or not? I'm interested in hearing about them. Before I go, if you want to show your support for the channel, give this video a thumbs up and smash the subscribe button and bell icon so you can be notified on future video releases like this. Make sure to check out my other videos in this Computer Science Education Week 2020 series, where I talk about my other experiences learning computer science and programming. Until next time, everyone stay safe, stay at home, happy holidays, and I will catch you in the next video.